Hey everyone, and welcome. Have you ever wished you could just quantify luck? I mean, really measure the odds of something happening, not just with a gut feeling, but with actual hard numbers? Well, it turns out you totally can. Today, we're jumping headfirst into the world of probability, and we're going to learn the language of math that lets us do exactly that, put a number on chance.
So let's dive right in with a question that I'm pretty sure has crossed all of our minds at some point or another.
The classic dilemma, right? You've got the sure thing, a pretty decent lunch, versus that tiny glimmering chance of a life-changing win. So the big question is, can we actually use math to figure out if buying that ticket is a smart move, not just today, but, on average? To answer that, we're going to need a few tools in our toolkit.
Before we can start calculating odds and beating the house, we need a way to talk about all this uncertainty. We need a common language, and that language starts with one of the most foundational ideas in all of statistics.
Okay, I know, that sounds a little formal, a little textbooky, but the idea behind it is incredibly simple. A random variable, we usually just call it x, is really just a placeholder for a number we don't know yet. Think of it like a question mark. What number will you get when you roll a die? How many emails will you get in the next hour? The answer depends on chance, and that unknown number, well, that's our random variable.
Now, to bring a little order to all this randomness, statisticians have helpfully split these variables into two main categories. It all depends on what kind of numbers they can be.
Okay, so here's the breakdown. On the left, we have what are called discrete variables. The key word here is countable. You can count the number of cars sold, right? 1, 2, 3. You can't sell 2.6 cars. Same for customer complaints. If you can count it in whole numbers, it's discrete. But then on the right, we have continuous variables. These are for things you measure. The length of a room isn't just 10 feet or 11 feet. It could be 10.2 feet or 10.217 feet. It can be any value within a range.
So we have these variables that stand in for all kinds of random outcomes. But how do we see the whole picture? How do we look at all the possible futures at once and know how likely each one is? What we need is a map.
And this is our map. A probability distribution is so much more than a list. It doesn't just tell you what could happen, it tells you the exact probability for each and every one of those things to happen. It's basically a complete roadmap for a random event.
Let's make this feel a bit more real. If we were to randomly pick one family, this table here shows the probability distribution for how many vehicles they own. It lays everything out from 0 cars all the way to 4 and gives us the exact chance for each. And you can see right away what's the most likely outcome: owning 2 cars, with a pretty high probability of about 45%.
And when you turn that table into a graph like this, boom, you can literally see the probability. The height of each bar just screams the likelihood of that outcome. This picture, this shape right here, that is the probability distribution. It gives you this instant gut-level feel for what's going on.
Now, for any of these maps to be legit, they have to follow 2 super simple, really logical rules. First, every single probability has to be somewhere between 0, meaning it's impossible, and 1, meaning it's a sure thing. You can't have a 150% chance of something happening, right? And second, if you add up the probabilities of all the possible outcomes, they have to add up to exactly 1, or 100%. That just means, well, that something on our list has to happen.
Okay, having a map is awesome, but the real power comes when you can use that map to find a single, really useful piece of information. Let's see how we can take this entire distribution and boil it all down to one powerful number that can help us make some smart decisions.
And that number is called the mean, or as it's more powerfully known, the expected value. Now, this is a really crucial idea. The expected value isn't what you'll probably get the next time you try something. No, it's the average result you'd get if you could repeat that experiment over and over and over again, thousands of times. It's the long-run average.
Let's put this to work with a real-world business problem. So, this company, Lorraine Corp., they're thinking about launching a new product. They've mapped out the possibilities. There's a 32% chance of a huge success, making them $4.5 million. There's a 51% chance it does okay, and there's a 17% chance it totally bombs and they lose $2.3 million.
So looking at these different futures with their different chances, should they go for it? What does the math say will happen on average if they were to launch hundreds of products just like this one over the years?
And here it is. By weighing each outcome by how likely it is, we find the expected value is a profit of $1.661 million. So,
Even with a very real risk of losing a ton of money on this one launch, over the long term, making bets just like this is expected to be a profitable strategy. This is the kind of math that drives decisions in business every single day.
Okay, so we've seen how a big corporation can make a smart bet. Now let's bring this powerful idea all the way back to where we started, with our $20 and that lottery ticket.
And here is the big payoff for us. If you calculate the expected value of a lottery ticket, you'll almost always find it's negative. For every dollar you spend, you might only expect to get back, say, 50 or 60 cents on average. The math tells us that, in the long run, it's a losing game. So the same exact tool that tells Lorraine Corp to go for it tells us that the guaranteed satisfaction of that lunch is the smarter bet.
What's really powerful about all this is that you don't always have to build these probability maps from scratch. A lot of situations in the real world follow these predictable patterns. One of the most famous is the binomial distribution. It's kind of like a shortcut you can use for any situation where you have a fixed number of tries, like flipping a coin 10 times, and there are only 2 outcomes, and the chance of success stays the same. For those cases, we have a formula that can map out all the odds for us in a snap.
And that really is the biggest takeaway here. These tools, they don't give us a crystal ball. We can't predict the exact future, but they give us something way more valuable. They give us that map. They let us understand the whole landscape of what's possible, so we can navigate through all that uncertainty with a bit of strategy and a whole lot of intelligence. So I'll just leave you with this question to chew on. Think about a decision you're facing, whether it's big or small. What are the possible outcomes? What are their chances, roughly? And if you could live out that decision 1,000 times, what would the average result be? What is its expected value? Thanks for joining me today.